If you like my dad's videos, please subscribe to QA Insights channel.
In this episode 2 of APM and Observability series, today we are going to see about Jaeger. Jaeger is a CNCF graduated project. It is an open source distributed tracing system. It is inspired by Dapper, which is from Google, and OpenZipkin from Uber. It is written in Golang and the UI is made up of React and JavaScript components. The core features of Jaeger is it is a distributed context propagation. So this term we will see in a demo so that you can understand better. And it will help you to monitor your transactions across your complex architecture. Also, it will help you to analyze the root cause of your failures and errors, and you can understand the service dependency. And of course, you can optimize your performance and latency issues, and it supports multiple storage backends such as Cassandra and Elasticsearch. And also there are community contributions over other database, but officially it supports Cassandra and Elasticsearch DB. To get started with Jaeger, you can clone the repository and then you can get started, or you can leverage the Docker. If you run Docker run command, it will start all the components and then you can access your Jaeger UI from the port 16686. Before we see about Jaeger and its functionalities, first let us talk about OpenTelemetry. Open Census and Open Tracing merged together to form OpenTelemetry. I'm going to post separate videos about Open Census and Open Tracing, but now let us concentrate on the OpenTelemetry part. OpenTelemetry is a collection of tools, APIs, and SDKs. If you use OpenTelemetry ecosystem, you can use it to instrument, generate, and collect the telemetry data. Telemetry data could be metrics, events, logs, and traces. So these elements will help you to analyze your software performance and behavior in the production environment. Jaeger falls under open tracing standards, and we are going to see in detail about open tracing and open census in the upcoming videos. Before we see about Jaeger UI, first let us understand the terms involved in that. Span is the building block of the open tracing system. So whenever you interact with your trace item, you interact with your span. So span is a individual unit of work done, kind of an activity in your complex architecture. Span consists of a name and then it will have tags and logs and other details. Tags, as you know, it is an annotation where you will use the key value pairs and you will mention the attributes. And similarly, logs, you will have the timestamp. So that is the difference between the tags and logs. Again, logs also you will mention the key value pairs. And Jaeger has a concept called baggage. So baggage, again, in the demo part, you will understand more about baggage. But baggage is, it will carry the data over across boundaries. So if you want to carry some piece of data across some process boundaries, then you will use the baggage. It will help you to trace the request. And the core implementation in Jaeger is using the tracer. So tracer only implements the spans. So that is the important logic in the Jaeger architecture. By this knowledge, you will have some high-level understanding about how Jaeger works. Now let us see a demo. In the demo, we are going to leverage the sample application called Hot Writes on Demand, and then we are going to fix the issues when running the application. Now let me open my Visual Studio Code here. So this is the clone of Jaeger tracing project. And if you go to the hot rod folder under examples, here you can see there is a docker compose.yaml. So we are going to leverage this docker compose.yaml to spin up the Jaeger tracing UI, and we are going to run the sample application. Now let me bring up my terminal, and first we have to start the Jaeger tracing, then we can start our sample application. Now in the new terminal window, let me just navigate to the examples folder and hot rod folder. And here we are going to use docker compose command, and we are going to mention -f and docker compose.yaml, and we are going to issue the up command, which will spin up the two containers. One container is to run your Jaeger tracing and another container is to run your sample application. So now our application is up and running. To access the Jaeger UI, you can use the port 16686, and to access the hot rod, you can use 8080. Now let me go to the browser and let us click on refresh under 8080. So this will open up the hot rod application, and Jaeger UI, if you just hit refresh in 16686, you will get this UI. Now let us go to the hot rod and try to understand how the application works in a high level. So here, if you see at the top left, we have one client ID, which is generated by your JavaScript, and we have 4 buttons. So each button represents the customer name to order a car. So whenever you click on this button, it will send the dispatch command service basically, and then it will display the license plate details and when the car will arrive. So those details will display in the UI. Before we start sending this particular request, let me open the network tab here just to understand what's going on when you click the particular button. So here we are going to issue only one request. We are not going to load test as of now. So now let me click on this Rachel's floral design. And whenever you click on this particular request, as you see, after 746 milliseconds, we have got the license plate number and the time duration. So it will arrive in 2 minutes. And here you can see there is a find trace button. So let us not click on this particular button as of now. I will tell you how to trace this request. Technical details of this particular request is automatically displaying in this sample application. So here you can see there is a request number for the client ID. So 4729 is the client ID and -1 it is adding. And whenever you keep clicking the button, it will increment the value. And the latency part, it is displaying 746 milliseconds. Since it is a sample application, you will see all the details just to help you and to get started. But in real world, you don't get this option. Only from the backend systems only we can monitor. Now let us analyze the two requests. So here the first request is, it is making a call to the config URL. And here we are sending some details in the request headers and query string parameters, which is nothing but some random number. And we got the response. And the next call, this is the application call, because as you see, it is making a call to the dispatch service. And we are sending the query string parameters, customer equals 123 and no one C, which is again a math.random call. And here, if you just scroll down, you can see the query string parameters, request headers, etc. And this is the call which is making in the backend, and it is contacting multiple components, and then it is getting the response, and then it is displaying it in the UI. So the whole latency, including the network calls, everything, it is around 746 milliseconds. Okay, now we are good with our hot rod. Now let us go to the Jaeger UI and let us understand how to trace this particular request and see what's going on in the backend. And whenever you launch Jaeger UI, you get a typical user interface. And on the left side, you will have the search options. And on the top right, you have the search box where you can look up by the trace ID. And if you want to upload some JSON file to analyze, you can do that using the JSON file tab here. And inside the search, it is automatically capturing the architecture. So what are all components we are accessing, application under test. So everything will display automatically. And operations, again, based on your selection, it will vary. And the tags, if you want to search based on some attributes, then you can use the tags. And look back, time-based filter here. And maximum minimum duration, where you can filter out based on the latency. And if you want to limit the results, you can limit the results. By default is 20. Let us go with the default values now. Before you click on find traces, make sure you have selected the right service, because we are directly searching the traces for the front end. So we have to select front end. But if you want to deep dive into driver or MySQL or Redis, we can select the appropriate service and then you can find the traces. Now I'm not going to click on find traces because we have to understand our whole architecture, how our application works. To understand our architecture, usually what we do is we contact the architects team or development team to share the solution design document and see what's going on in our application. But when you have the Jaeger-like tool, you don't need to get the solution diagram. Basically, it is very helpful, but just to understand how your request travels across multiple components, you don't need the architecture diagram. You can use the Jaeger UI to see what's going on. In the top left, you can see there is a option called system architecture. And if you just click on the system architecture, you will get two tabs. One is the force directed graph and another one is DAG. DAG stands for directed acyclic graph. And here, if you just zoom in on the force directed graph, here you can see if you hover your mouse on the component, the node, you can see how it is interacting with the neighbor nodes. So here if you hover over to front end, so front end is making a call to three services: driver, route, and customer. And similarly, driver is interacting with Redis database. And here if you hover over your mouse on the customer node, you can see it is interacting with MySQL. So now you got some idea. And if you click on DAG, here you can see more details about how many requests have been sent till now. So here if you see the front end, there's our initial root element. And if you launch the front end, it is making a one call to the customer, and one call to driver, and 10 calls to route. Why 10 calls? We do not know yet. We will see when we trace the request. And the driver is making a call to Redis around 14 times. So there are 14 requests being sent from driver to Redis, and customer is making a one database call. So this is our whole architecture of our application. With this knowledge, we are going to deep dive into tracing and see what's going on and how to optimize. Now let us go to the home page of Jaeger UI here. And now let us click on Find Traces. And if you click on Find Traces, as you see, it is displaying around 6 traces has been found. And here you can sort by most recent, longest first in terms of latency, shortest first, most spans, least spans. And if you just scan the results, definitely you can easily identify which call we are going to trace. Of course, it is a dispatch call because as you see here, there are 51 spans and 3 errors, and it is interacting with all the 6 components. And this is the timestamp when we made the call. And the total latency is 708.35. But if you go to hot rod and if you see your latency, which is 746 milliseconds, of course, it is very high because of the network latency. Jaeger will give you only the backend stuffs, not the UI. So that is why it is displaying higher in here and lower in the Jaeger UI. Okay, now we are somewhat clear about this particular traces. Now we have to deep dive to see what's going on in the backend. Now let me click on this particular element and click on the front end HTTP GET, and then it will open the trace information. So this is what you will get when you click on the results. So this is the trace view, and here you have to observe everything here. Whatever you are seeing, everything is important to deep dive into your performance issue or any other issue. So here as you see at the top left, it is displaying the trace start, duration, number of services it is interacting, depth, and total spans. There are 51 spans, and here you get the visualization in the timeline view, and you get the service and operation here. And there are small UI aspects here. If you want to expand, you can use this. If you want to collapse or expand all, collapse all, everything is self-explanatory. And you have to deep dive by clicking on each item. So there are multiple ways you can deep dive. First, you can start from the top to bottom. So that is one way, or bottom to top. That's another way. Or you can see whichever is longest span, you can start from there. Just to explain the concept clear, I'm going to start from the top to bottom. So as you know, the longest span. So this is the span actually. So we see this color, right? It's a span. So it is an activity. So it is a unit of work done with some details. So in this case, the longest span is of course the root element. So root element is making a call. This is the call we are making actually from the front end to dispatch. So if you click on this particular span, it will expand, and then here you will see the tags, process here, and the service name, front end, duration, start time, and also the log information. So we will come to this particular log later. And now let us go in depth. So this particular dispatch, it is making a call to the customer. And if you expand customer, you can see the tag information, the process. Similarly, the customer is making a call to the MySQL database. So if you see here, so this is how your request spans. Now, if you click on this log information here, you can see there is an event happened and acquired lock with 0 transactions waiting behind. So there is no lock issue, and it is able to extract the information within 3.45 milliseconds. And total duration of this particular span is around 276 milliseconds. Well, everything is good. So no issues. As you see, everything is fine. But if you go further, after completing the customer call, the front end is making another call to the driver service. The operation name is find nearest. So it is trying to find the nearest drivers. And if you expand the log information, you can see the relevant log. So it is searching for nearby drivers. And there are 3 errors. If you see, get driver after error, retrying. Error is read is timeout. So here you can see error equals read is timeout. And there are totally 3 errors. And if you just see here, 1, 2, 3. 3 errors. And it is making 10 get driver calls. So if you see the number of get driver calls here, should be 10. So now let me count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have to ignore the error calls. But total successful call is around 10, and everything is like a stair step case. If you see, everything is a stair step. So one after another. And if you want to confirm the number of calls, again you can see in the log information. So number of drivers is found 10. So this is what it is doing, this particular call. And after getting the 10 drivers, it is making 10 route calls. If you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 route calls. If you just scan your traces, you can see it. And if you expand this particular span, you can see we are making a call to the route with the query string parameters with 115.277 and the pickup. And if you expand the next route, again you can see 115.277 and the pickup will vary. So like this, there are around 10 route calls. And these calls are, you can say it is somewhat parallel. If you see 3 here, 3 here, again parallel and stair step, parallel and staircase, parallel and staircase. So this is the pattern we are seeing. Okay, now everything is good because it is just a one request. So one request means it is happening around 700 milliseconds. But this might not be the issue. But what happens if we send some load? So how do we fix the issue? So that is what we are going to see now. Since we have seen how this particular call works, we can understand how our application works in the real time. But now let us inject some load. So we're not going to use some tools like JMeter or some other tool. We can randomly click on the customer name just to give some load, and then we can see what's going on in the trace information. Let us go to the application and let me close this developer tools. And let me click on this particular customer rapidly. Let us send 10 to 20 requests pretty quickly. Let us start now. Now, as you see here, I have clicked around 10 to 20 times rapidly, and the response time is around 746. This is the first response time. The response time is increasing whenever we are started sending the more requests. So this is what will happen if you deploy this application as is in the production. Eventually the application will hang, and then it will go to not responding, and then eventually it will be dead. So how do we use Jaeger to see what's going on in the backend, and how do we fix the issue? Now let us go to the Jaeger UI and let us click on find traces, and let us sort it by longest first. As you know, again there are around here you can see 1.83 seconds in the backend the routing calls duration, and there are around 50 spans, 3 errors, 2 errors, etc. Let us pick one. Let us pick this one and let us go inside this. And as you know, here by seeing this trace ID, we can see there is something going on in the MySQL. So why MySQL? Because the number of the duration, if you see, it is 1.39 seconds. The span duration was less earlier, but now it is very long. We can click on this particular span and see what's going on in the logs. If you expand the log information, I am seeing something interesting. One is waiting for log behind 4 transactions. So this is the transaction which we are selected, 4729-26, but it is waiting for lock behind 4 transactions, which is 22, 23, 24, 25, and acquired lock with 1 transactions waiting behind. So it is taking 1.4 seconds to acquire a lock, which is bad. So usually this issue should not happen. We have to optimize the MySQL database. When it comes to hot rod, the MySQL and Redis is a simulation basically. So it is not actually we are running the components. Just a simulation just to learn the concept. Now with this information, we are going to deep dive in the code part. So what's going on in the backend code with respect to SQL Select. So that is one thing. And if you have access to the code, we can see what's going on in the real-time project. But since it's a demo application, yes, we have the access to the code and we can see how to fix it eventually. But before that, how it is correlating, how this request is being sent, how it is traversing. So that information you have to understand. So this is called baggage. So baggage, as I said right in the slides. So if you want to transfer some piece of data across the boundaries, Jaeger uses a concept called baggage. So by using the piece of information, you can easily correlate what's going on before and after. Waiting for lock behind 4 transactions. So we are just looking back and it is automatically capturing the information, what request it is waiting. And also I have used another term, another core feature. Now let us go back to the slide. We can see here context propagation. So this is the term, right? So how Jaeger helps us in the context propagation. And if you click on the root element here, root span, and if you expand the logs, so here you can see what's happening for this request. Clearly you can see starting from 0 to and end. So this is where we are getting started, dispatch, and this is where we are getting ended. And what details we are sending, everything will display eventually one by one in a clear way so that you can understand better what's going on with this context. Suppose if there is no Jaeger-like tools, what you have to do is you have to get the logs information and then you have to slice and dice. Even the log information also will not have only one request. It will have millions of records, millions of timestamps. So you have to slice and dice. So that will take more time and you may not be able to understand what's going on. But by tracing, by sending the piece of information to traverse across the request, Jaeger-like solutions will help us to pinpoint what's going on. So that is the power of this tool. Here now we have seen 2 concepts. One is the context propagation and the baggage. So here if you expand this information, you can see the event type is baggage. And the key is customer and value is Rachel's floral design. So this is what it is carrying over across your, we can say event. And at the end, you will get the success dispatch. Okay, now we have to fix the issue, SQL Select. So how do we fix the issue? Now let us go to VS Code to understand what's going on the back end. So in the VS Code, if you go to customer folder under services, customer and database.go, and if you go to the line number around 88, 89, here you can see the log context. So this is enabled, and if you can see the comment here, so simulate misconfigured connection pool, that only gives one connection at a time. So that is the culprit actually. So one connection at a time. So you cannot make use of the pool. So we have to configure the optimized DB settings so that we don't get the MySQL lock issue. So to fix this issue, there is a command you have to send. So let me stop this particular application. And if you go to the docker compose.yaml, and here what I'm going to do is I'm going to add help argument, and I'm going to run the docker compose command again. So this help will display the arguments it can be accepted. So actually it's a sample application, and then you can easily configure your settings. So now let me go to the help output here. Okay, this is not helping us. So let me cancel this and let me delete this all, and let me send only the help command here. Okay, now if you see here the line number, there's no line number here actually, but you can see the usage, examples, hot rod, all, customer, driver, front end. And if you just scroll down here, and if you see the help command here, there are 3 fixes. So one is the fix DB query delay duration. So by default it is 300 milliseconds. And also there is a disable DB con mutex. So this is the DB connection settings. So if you send this -d and -m, this will fix the issues with respect to database. Now let us go to the command here, the line number 14 in the compose, and we have to send in a comma separated argument. So one is -d, which is say let us reduce it to 100 milliseconds, and again we are going to send the -m, which will fix the connection. Now let us send the compose command again. So here you have to use the comma separated value for all the arguments. Now let us go to the application and hit refresh. So our application is working fine. And similarly, if you go to Jaeger UI, here also you can see our application is working fine. Now let us go to hot rod and let us send the request immediately. And if you see here, there is an increase in the response time, but we should not get the MySQL error. So now let us go to the Jaeger UI and click on find traces. And let us sort by longest first, and let us expand the trace information. And here if you select the MySQL and see, you don't see that issue anymore. So everything is under around 140 milliseconds. So we don't get the higher latency for the MySQL call because the issue has been fixed. So this is how you use the Jaeger UI. But here, if you just notice, still there is an issue actually. And if you just scroll down, you can see this particular pattern. So again, it's a stair step. So it is not sending the request parallelly. So it is waiting for one set of request, and then it is starting another set, and which is causing the high response time. So even we can fix this issue also. To fix this issue, again, we have to go to the VS Code. And if you just send the help command here again, and here if you see the route worker pool size. So by default, it is making use of only 3 worker pool. So that is why we are seeing this 3 requests. There are only 3 workers which is taking care of this routing. So since Go is a very lightweight in terms of Go routines, we can increase the numbers to say 100 or 1000. Now let us go to VS Code. Now let us add the -w comma to 100. And let us start the application again. Now let us go to the browser and hit refresh. And now let us quickly send the requests. Now if you see, we don't see more than a second. Even if you click on pretty quickly, you don't see any increase in the latency. Now let us go to the Jaeger UI and find traces, longest first. Click on traces. And here if you see here, there is no staircase. We are getting the parallel requests. So everything is parallel and no MySQL error. Redis, this one we have because it is a timeout basically. So we have to increase the timeout. But you got the idea. So how we can traverse the request and how we can find the information. Before we wind up this tutorial, I would like to share another piece of information with respect to Jaeger. So Jaeger, it is not just for tracing, it also emits some metrics basically. And if you go to the 8083 port /debug and vars, so if you have enabled the debugging, you can see a lot of metrics here. So this metrics will be very helpful for your analysis. For instance, if you go to the bottom of this particular JSON output, and if you just scroll to the end, you can see the percentile report for the route error. And then if you just scroll up, you can see an interesting calculation for the customer. So here if you see the parameter route calculation. So to calculate the route, how much time it took for the customer. And if you take the Rachel floral design, it took around 0.5 seconds. And similarly, you can see a route calculation by session, which is 6459, which is session ID, which took around 2 seconds. So by this, you can also deep dive into your some of the business details. So how long it took for this particular customer, how long this took for this particular transaction. So those calculations also, it will be very helpful for your analysis purpose. But you have to enable this logging, otherwise you don't get this particular information. So by this, we are just ending up the Jaeger tutorial. I hope this tutorial is very helpful to deep dive into the open tracing and other distributed tracing aspects. Thanks for watching. Have a good day.
If you like my dad's videos, please subscribe to QA Insights channel.